And so I'm Etta Pisano. I'm the new Chief Research Officer for the ACR, and I'm happy to be here today. Thanks, Charlie, for inviting me to speak. I had slides, but and I don't think they made it. And that's sort of the
They were really big data.
They didn't make it, but that's okay. And I'd rather talk to you anyway. I kind of debated not having slides. Oh, you can't hear me. You need me over there? Okay, I'm getting over here. Okay, so I feel like what I have to say sort of ties together the previous talk and sort of focuses on what we do here in this office and what the ACR does more broadly about how important the kind of work we do and how it interfaces with what Don just talked about. You know, I think, thank you for that long history lesson, because I didn't know a lot of it. I actually came in around, as you heard, for RDOG 5 in the 90s. And I think the theme that Tom really laid out beautifully was how innovative we as a specialty and as a profession are. So this office has really led some amazing innovations. And by that, I don't just mean, obviously, the IT stuff that was done here to support DMIST, and now it's, you know, obviously advanced much further than that. But also all the things that have gone on in radiology and radiation oncology in my lifetime. I mean, I started being a radiologist I took my boards in '88. My dad is a radiologist, and so he took his boards in the mid-'50s. And the change that the two of us have seen, and my father was a radiation oncologist too, by the way. It was a joint specialty. So, you know, that's why we're still together, I think, because we started out together. But the evolution of what we've done and the data that we've amassed to prove that it works and helps people is phenomenal. And as Don mentioned, ACR, I mean, RSNA, the meeting, was all about, you know, really huge amounts of information about AI. And I think when you hear about that, and Don just laid out a lot of ways AI is going to affect us, I don't think it's very clear how we're going to get from here to there. And I think DSI, which is the Data Science Institute that the ACR, I'm getting my organizations backwards, but the ACR has founded to help us implement artificial intelligence in our practice. That's a good piece of what needs to be done. I think, though, you know, there's lots more to be done as well. I mean, I think everybody in this room has experienced the shortcomings of clinical medicine today. You know, a good example is digital data doesn't always end up. My slides didn't get here today. I emailed them yesterday. They're not here today for unclear reasons. That happens in clinical medicine every day. You know, Geraldine McGinty, who's the Board of Chancellor's chair this year, has lamented the fact that she, as a breast imager, has to go get a disc on a patient and bring it in from another, you know, it might be a hospital that's right across the street, that you can't get the data except on a disc. That's just ridiculous in 2018 and beyond. So that's an example, but there are lots of other examples that affect your health more directly than the inconvenience of carrying a disc. You're given a drug that's been tested on a population that may or may not represent you. You're tested with IV stuff. You know, people may give you contrast agents that aren't good for you as an individual. Everyone in this room is different. Every one of us has a different genome, has a different set of environmental factors. The environmental factors are very important, and the background that you grew up in, and your own genetic information. And we really aren't right now very well equipped to move from what we do for everybody, the population, to what we do for individualized. Personalized medicine means figuring out what those unique factors are. So how does that fit that affect your health, that we can do better at? So how does that fit with this office and what we do as radiologists and radiation oncologists and what the ACR is doing for its members? How it fits is we're going to be the ones to figure that out. That's the kind of research we're going to be doing in the next decade or two. We're already doing it in TMIST. For those of you working on that project, we're already collecting blood and buccal smears and genetic material and demographic information, and that information is going to be unbelievably fertile for the future understanding of not just breast cancer, but other cancers and, frankly, other diseases. Because the people who are donating that material or as volunteers in that study, they're going to get other diseases too. We're going to be able to figure it out. Finally, the innovation of the ACR and this office, you know, it was really nice to hear about that because I really didn't appreciate when it was going on how innovative it really was. I mean, that comparison to the other two talks you gave was really quite remarkable. this is really, our profession of radiology and radiation oncology and the ACR is really a cutting-edge, innovative organization. I don't know, maybe all of you appreciate it. I don't think I appreciated it as much until I started working in the ACR in 2016. That's when I came on full-time. Let me just give you some examples and where I think we're going. You know, Triad. Everybody knows about Triad in this room. I'm sure everybody knows what it is. You know, it really is an innovative thing to be able to pull up images and de-identify them and use them for all sorts of purposes. I mean, it's not just research. They're used for quality and safety. They're used for education. They're used for all sorts of things. In addition, we have DART now, and DART will evolve over the next decade or so, I hope maybe faster than that, so that we can actually interrogate the medical record and pull data up connected. I think Don just mentioned finding patients for clinical trials. Well, that's not the half of it. If you think about it, the promise of AI is really going to be realized once we can actually interrogate medical records and understand how things we don't understand right now. Not only do machines not need to look at images, they don't need to look at printouts of data. They can make connections between things that we as humans can't. So in my view, this platform that has been created inside the IT department at the ACR and which is being utilized by all of us has incredible potential. I'll just give you a couple examples. And we don't have this capability yet, but I believe we can develop it. I mean, I've talked to Mike Tilkin and the people in Reston who work with Mike, and essentially, if we do what we think we can do, I mean, I'm not the technical person who can do it, by the way, we already have a grant to test this concept. The Cure 14 grant is actually a grant to pull cases out of the medical record at Jefferson, at Penn State. We will be able to put a platform on a local site, interrogate the electronic medical record, identify cases that fit certain profiles, and then use them for research projects. So let me give you an example of how AI in that kind of experience might be used to find new knowledge. So everybody's focused on doing the same things we do right now. Like, okay, we find a breast cancer on a mammogram. That's great if a machine can do that. We can already do that pretty well. Can't do it perfectly, we can do it pretty well. Here's an idea of something that we could do that we can't do right now. And by the way, I chose an example from neuroradiology because I want everybody to think I just think about breast imaging all the time. I actually vetted this example with Alex Norbash and Chris Whitlow. Alex Norbash is a neuroradiologist, the chair of our neuroradiology commission, and Chris Whitlow is on the, hi, I didn't even see you there. I haven't seen you in a long time. Chris Whitlow, I just recognized you. Chris Whitlow is at Wake Forest, and he's a member of our Head Injury Institute, maybe soon to be the chair of that. Anyway, here's the example. We have patients who have subarachnoid hemorrhage. And everybody who doesn't know what that is, blood in the head. It kills 50% of the people who get it. It's usually caused by either a berry aneurysm, little outpouching on a blood vessel that bursts all of a sudden, which is probably genetic abnormality, or an AVM, which is another genetic abnormality, and they lurk inside people and they all of a sudden burst. And they kill 50% of the people who get that. When they bleed, they kill 50%. In about 5% of the people who have that, 2 or 3 weeks earlier, they have what they call a sentinel headache, where they get a bad headache, and they go in, and they get imaged, and they get told, oh, it's just a bad headache here, take some aspirin or some other drug. 2 or 3 weeks later, they come back with a catastrophic bleed, and those 50% of those people die. Chances are the imaging is not perfect 2 or 3 weeks earlier, and there may be things on those images that we as human beings can't detect. All those people are out there, they're getting imaged, and we know who they are. We could do a retrospective study, you know, and pull out all the cases. If we have this machine that can go into the medical record and find them, no human being has to find those people. We look for the diagnostic code, subarachnoid hemorrhage. We go back and we look for the people with imaging 2 or 3 weeks before for headache. And we take all those cases. We don't necessarily, Don, there's one thing Don said that I disagree with. We don't have to put all the data in one place. There's something called the federated data model that Mike works with. Essentially, we pull the cases up, we allow the AI algorithms to learn off those cases, and then we have a new tool that helps us find the cases that had the ultimate subarachnoid hemorrhage. We also have to have a control group, by the way, just to do this experiment. The people who had headache who didn't have it. And we find the findings on those images that the machine can see that we can't. now all of a sudden the AI algorithm says when someone comes in with a sentinel headache or a bad headache, you can apply that AI algorithm and say, maybe you should look a little more closely at this person. Maybe you should do an angiogram. Maybe you should do a CT angiogram. Maybe you should do something to work them up because this person has the signs that big group of people that has the ultimate subarachnoid hemorrhage has. So this is an example. This is an exciting example of how we can do new science with these tools. And I predict that the ACR is going to develop these tools. We're going to be right at the center of this. This is not, and it's not going to be just us. We're going to be partnering with industry. We're going to be partnering with government. We're going to be partnering with lots of people. We're going to do this together with the healthcare system. And frankly, it will be good for all of us. Now, there are some issues. We got to worry about privacy. We got to worry about patient safety. We got to, and by that I mean mostly privacy. Although there's some other things. Insurance companies can get a hold of data and do bad things. I mean, people can use your private and medical information for bad ends. But I believe we're up to that challenge, and I believe this organization is going to lead that because we have led that. I mean, that's what was nice about Tom's talk being right before. He told us how we were the leaders in the world on getting cases amassed and de-identified and collected, and all the data with it for clinical trials. We're going to do the same thing. And by the way, it's not just about caring. It's mainly about doing better care for our patients. But I agree with what Don said. It's also about the financial side of things. If you can do this better for patients, if you can individualize for patients, there will be it'll be better financially for the entire system, including all of us in this room who pay for health care. And after all, that's good for everybody, right, if we can do things more efficiently. So I don't feel the slightest bit embarrassed about saying people will have a bigger margin. The people taking care of patients will make more money, which means they'll have the mission. There's an expression, no margin, no mission. Guess what? What is that mission? It's taking care of patients, and it's doing good research, and it's teaching people. So those are great missions to have, and this organization is in the middle of all of them. So I'm proud to be part of this, and I thank you for inviting me here today.